Okay, so now we're going to take a look at series rather than sequences. And a series, well, that's when we add up the terms, right? So supposing we had a arithmetic sequence, which was 2, 5, 8, 11, and so on like that. You can see it's arithmetic. We can see that U1 is equal to 2 and D is equal to 3. Well, a series would be, for example, 2 plus 5 plus 8 plus 11 plus and so on like that, right? Okay, so that would be what a series is. Now, if I defined this series and I said, well, I wanted S of 3 and S for the sum or the series, right? Okay, well, that's just going to be 2 plus 5 plus 8. That is going to be 15. If I wanted S of 4, that's saying to me I want the sum of the first 4 terms of this one. Well, that's 2 plus 5 plus 8 plus 11. Well, that's going to be 26. So that's the sort of terminology we can start to think about. But there is a little bit more we need to understand before we can have a look at some questions. We're going to introduce this symbol, and this is the Greek capital sigma, and this is what's used as a shorthand way to show that I'm adding up and I'm summing certain things. So let's take a look. Right, so any reference to a formula is put on the right hand side, look, okay? And what we do is we input numbers in. So at the bottom here, we have the first input number to put in. So what this is telling me is that, well, I need to find U of 1, whatever that may be, and I'm putting 1 in there first because that number there is really important. That's the starting number, plus U of 2, plus U of 3, and so on. Now, at the top of the sigma, we're going to put another number. So in this general case, let's just put an n there, right? We're going to stop once we get to the nth term. And that is how this is kind of working, right? So let's just make up a really simple example to get you to understand this a little bit better. Above there, look, you've got the general one, but it doesn't have to look like that. So what about if we set up a sequence like this, and we'll put some different numbers in, look, okay? And let's put it like that. Right, so what does that mean? Well, first of all, this number is the first one that's really important. This is going to tell us the first value I should input in as k. So clearly it's going to be 3, right? So the first value in my sum is 3 plus 3, which is, well, we know it's 6. We'll come to that in a moment. The next one, it keeps going up by 1 every time, is going to be 4. The next one is going to be 5. The next one is going to be 6. The next one is going to be 7. But I'm stopping at that point. This point is where I stop, and I know where to stop because it is indicated on the top of the sigma sign. So all I need to do then to work out this is just to add up these numbers. Well, this is 6 plus 7 plus 8 plus 9 plus 10. Now, a quick trick that we can use to add this up is to collect them in pairs, look. So that's a 16, and that's a 16. So I've got 2 16s, which is 32, plus an 8. So I can see that this is 40. So that's the notation that we're thinking about. Now, let's get into some more examples of how this works. So in this one, we've got some square numbers. This doesn't have to be arithmetic, okay? Series notation like this can be used for anything. So first of all, let's write down an expression for S of n. Okay, well, in general, easy terms to understand, S of n is going to be 1 squared plus 2 squared plus 3 squared, and so on, all the way up to n squared, right? This is the stopping number, right, up to the nth term. So that might be a nice way of doing that. Now, in terms of my series notation, well, we can do that too. S of n is going to be equal to, well, clearly, look, I'm starting with an input of 1 and I'm ending with an input of n. So we'll say I'm starting with a k equal to 1 and I'm ending with a k equal to n. What's happening every time? Well, I'm squaring it. So there we go. That would be the best way of writing this in terms of that series notation. Okay, let's do, that was part A. Let's do part B now. So part B, well, we've actually got to find it now for n is to 1, 2, 3, 4, and 5. So S1, well, that's easy. That's just going to be 1 squared, which is 1. S2 is going to be 1 squared plus 2 squared. Well, that's going to be 5. S of 3 is 1 squared plus 2 squared plus 3 squared. Well, that's the original 5 plus 9. So we're going to have 14 there. Now, you might be thinking there's a trick here, isn't there? I just have to add on the next square number to the previous, and you'd be right. S4, we could save some time. It's just going to be S3 plus 4 squared, isn't it? So I'm going to end up by having 14 plus 16, which is 30. And then S5 is going to be S4 plus 5 squared. Well, that's going to be 30 plus 25. That is going to be 55. So there we go. We can use this and get a grip on really understanding what a series is using this series notation. Now, I've already done A, so let's just jump in and have a quick look at this one. Let's see if we can work out what on earth this means. Okay, so we're going to have to work out some numbers. So let's just put them straight in. So this will be equal to 1 over 2 to the 1, and I've put that 1 in because this is clearly telling me I need to do that, plus 1 over 2 squared, plus 1 over 2 cubed, plus 1 over 2 to the 4, plus 1 over 2 to the 5. And I'm stopping at that point because this number here is telling me I stop at 5. So if I just simplify these, I'm going to have a half plus a quarter plus an eighth plus a 16th plus 1 over 32. Now, we'll assume this is a non-calculator question, so let's rewrite all of these with a denominator of 32. So that's going to be 16 over 32 plus 8 over 32 plus 4 over 32 plus 2 over 32 plus that 1 over 32. Now I can keep that denominator the same and add up those numerators. We are going to come out with a 31. So my final answer to that one is 31. Okay, now just a few tricks to kind of help us here, okay, are explained here, look. Okay, so let's just break down what these mean. And these are some rules that we can use to help us with our series. So if, for example, I had let's make it up, look. Okay, so I'm going to make up an example I can kind of show you. So like, for example, we've got k equal to 3, finishing at 9, and we had 2k plus k squared, right? So clear, I'm not going to go through all of this, but you could easily say, well, it's 2 times 3 plus 3 squared plus 2 times 4 plus 4 squared, all the way up to 9, and then we'd stop. But what I'm trying to get at with this particular first top line here is I could split this into 2 pieces. I could work out the sum from 3 to 9 of 2k is one sequence. I could also work out the sum from 3 to 9 of k squared, and I could add those together. That is going to be absolutely fine. So that may help us. And also, if we have something, let's use the same numbers again, look, okay? Let's just rub this out. The second line of this is saying, well, okay, if I had this, well, I could, that 2 is just a constant. So what I could say is, well, I could pull out the 2. I could work out the sum of just k from 3 to 9. So 3 plus 4 plus 5 and so on up to 9. And then get that sum and then multiply the whole thing by 2. And I'm going to have exactly the same answer. All right. Okay, now we'll have one little look at just a little example of some of this right now. And then you can get on with your work. So let's take a quick look at one of these. Let's just pick B, okay? We won't give them all away. Right, we'll just do B. So we're going to write down an expression for Sn. Okay, so let's do that. So let's start off by thinking about the sum. Well, I think you can input and start with any number as long as you've got a correct formula. Let's start with k is 1 and end with n there, look. All right, and that's going to mean that we've got n terms, just like what we want. Now, the next stage is to think about that formula. So we already know a formula for this, and that's why I picked this example, because it is arithmetic. So we could just very quickly say that U1 equals 42, D is equal to -5, UN is equal to -5, 42, I should say, plus n minus 1 times -5, which is going to be 42 minus 5n plus 5, which is 47 minus 5n. Okay, now in terms of what I need to write here, well, I need to put that in, don't I, to generate the terms that I'm looking for. So I'm using k, you see, inside this. So I'm just going to write 47 minus 5k. And if you're ever unsure that this is right, well, check it. If I put k as 1 into this, am I going to get the first number 42? Yes, I am. If I put k as 2 into this, will I get 37? Yes, I am. So this is the correct expression that I'm looking for. Okay? Right, I'm not going to move on to part 2. I've covered that earlier on in the video. Hopefully that helps you to see how you can start writing things with this series notation, and you can answer that question.